So this is where we left off in the last video. We said, how can we find this crazy area under curve F bounded by, on the left, x initial equals A, and on the right, x final equals B. And the idea is that maybe we can enclose this strange area inside of an area that we're familiar with, a rectangle. So if we use the intersection of the side of the rectangle and the curve on the left at this one point at x equals A and form a rectangle by going straight to the right and down, that will give us the rectangle from A to B with area A sub 1. And you can see that if we shade this in, the area is going to be lacking just a little bit. It's going to be an underestimation of the area under the curve. So A sub 1 in the rectangle is approximately equal to A, the area under the curve. This rectangular area using the left endpoint, as you see here, is actually a little bit too small, and that's fine. So let's consider the other possibility from going from this first example with a left endpoint that was a little too small. Let's go to the right endpoint, which is going to be a little too big. So here we have the boundary x initial equals A, x final equals B, and we've touched the curve with the right endpoint this time on the rectangle. And that causes us, when we make a perfect rectangle, to have a little too much area. So A sub 2 is approximately equal to the area under the curve, but this rectangular area using the right endpoint is just too large. Okay, so let's refine. We're going to refine the rectangle idea as we did with the triangles in the previous video, the fan. We're going to refine it with the idea of a finer mesh, and we're going to add up the areas of little smaller rectangles. And we're going to just do it with 3 rectangles under the curves. On the left side, we're going to start by doing it with 3 rectangles that have the right endpoints. So here on the left, we have the function in both cases. That's our curve. We have the same endpoints, but we have our first endpoint on the left side of the first rectangle. All right, and then we're going to go drop down the left side of our rectangles and go to the top. Now we're going to go across from the points on the curve, and that's going to give us 3 areas, A sub 1, 2, and 3. And of course these areas are going to be a little bit too small. There's a gap on top where we don't have all the area included, but at least it's a smaller gap. It's a better estimation when we have more of the rectangles. We will add all those areas up together to get a result, but still it will be a little bit too small. And over on the right side, we're going to look at right endpoints for our rectangles. So now we're going to touch the curve on the right side of each of these rectangles, and that's going to cause our rectangles to ride a little bit higher than the actual curve. And in doing that, you see we're getting a slight overestimate of the area under the curve. So both of them are closer than they were in the pictures right above them where we had a single rectangle. They are closer, but they're still off by the same inclination. For the left endpoint, they're a little bit too small, the areas, when you add them together. So we call that a lower estimation. For the right, they're a little bit too high. So we call that an upper estimation of the area. So lower estimates occur when we use the left endpoints, and the upper estimate occurs when we use the right endpoints. So here we have area is equal to the sum of the little areas, and that's too small. Okay, over here using the right endpoints, we get too much. So the area under the curve is approximately the sum of the little ones, but in this case with the right endpoint, the area that we add up will be a little bit too large. So we're going to have to come to some agreement somewhere in the middle or come up with a different idea.